Hello, everyone, and welcome to Field Notes. My name is Crystal Briggs, and I am a soil scientist in Mount Vernon, Washington, and the Field Notes Regional Representative for the Northwest Soil Survey region. As a regional representative, I serve on the Field Notes Review Committee. The Review Committee solicits and selects topics for each webinar. We have selected one exciting topic for today's live event, but first let's go over a few housekeeping items. This is a Microsoft Live event, not a Teams meeting, which means you are joining today's webinar in listen-only mode. We encourage you to ask questions at any time using the Q&A panel. The Q&A panel should open by default. However, if for some reason your Q&A panel is not open, simply click on the question mark icon located on the upper right side of your screen. For closed captions, turn on the live caption button located on the lower right corner. Today's session is being recorded. Recorded sessions are available in Teams on the Field Notes channel and the Soil and Plant Science Division's YouTube channel. Again, thank you for joining us. I hope you enjoyed today's session. With that, I'd like to turn it over to the Field Notes moderator, Neil Dominy, to tell you a little more about today's webinar. Take it away, Neil.
All right, thank you very much, Crystal. It's my pleasure today to introduce Jenn Mason of the Soil Services and Information Branch. She's going to be presenting today on a very large, significant opportunity that we all are working for and working with over our history, the 125 years of soil survey. Jenn, best of luck with the presentation today.
Thank you, everyone. I really appreciate your time today. Let me share my screen. Can everyone see my screen okay? Right. Greetings and thank you for joining us today as we celebrate the 125th anniversary of the Soil Survey Program and the National Cooperative Soil Survey. This will be the first in what will be a three-part series that will take a historical journey across the soil orders map of the United States of America. For practical purposes, if a location resides in an area of no data, a soil order or multiple soil orders that are close to that location will be selected. We're doing this in a little bit different format today. Paul and I always really prefer the story map format. You'll see just a quick housekeeping note for the story map across the soil orders map. If you zoom in one section here a little bit closer, you'll see that these soil orders will appear, but I also have them outlined in the content section on the left pane. When we do send the story map out link, which will be much later after the three-part series is complete, you'll see that these links typically relate to the photo content here in some sort of fashion. And we have a Soil and Plant Science Division link for folks that are outside of the Soil and Plant Science Division to learn a little bit more about us and the National Cooperative Soil Survey. So without further ado, we'll stop on the soil order of one of my favorite soil orders, the ultisols. To some people, 125 years may seem like a very long time. However, when it comes to the production of soil surveys, it is a small snapshot in our time. Our knowledge of soils in relation to the 5 factors of soil formation increases as we evolve with new technology, types of field equipment, and ideology. Our experience observing, investigating, and researching in the field leads to new standards, methodology, guidance, and new and improved products for public use. We've come a long way from the plain table soil surveys. Our products encompass much more than soils data, information, and maps alone. What do we as the Soil Survey Program and the National Cooperative Soil Survey look like in the modern world versus 125 years ago? The Soil Survey Program and the National Cooperative Soil Survey has outlasted soils programs in any other country. We set the standards for the world in classification, mapping, and laboratory procedures. We provide a unique product for this country in a unique way. How did we become what we are today? What do the next 125 years have in store? Let's take a virtual tour from the past to the present and explore what the future might hold. So we'll go as far back as 1820, and we'll be stopping in the soil order of insectisols for this particular journey. During the 19th century, scientific developments in the field of geology and agricultural chemistry directly contributed to the birth of the Soil Survey Program in 1899. Inquiries regarding the nature of soils were primarily viewed from a geologic perspective. As interest in geology and agriculture grew, so did the interest in the nature, the role, and the function of soils in agriculture. In 1818, a lawyer by the name of Amos Eaton began to draw attention to the connection between geology and agriculture. Eaton stated that all soils, excepting what proceeds from decomposed animal and vegetable matter, are composed of broken fragments of disintegrated rock. From this fact, it is natural to infer that the soil of any district might be known by the rocks out of which it formed. So here we're looking at maybe some early conceptual views of what we now call residuum, but those views were a little bit more broad-based than what we have today. In 1820, Eaton, under the direction of the Agricultural Society of Albany, New York, completed the Geological Survey of Albany County. In this survey, soil samples were collected and analyzed for amounts of what was called silex, which is now what we know as sand. And I'm not going to pronounce this correctly. I know I'm Southern. I introduce vowels where there are none. Alumine, clay, soluble salts, organic matter, carbonate of lime, oxide of iron, and water. You kind of want to add Ive-Newt there maybe, but anyway, in addition to soil analysis, a coarse soil classification scheme was established. There was a distinction, and here we go again, my apologies for the mispronunciation of this because there was no pronunciation associated with the document. Geest, geest, or guest, however you prefer to pronounce this, was described as the proper unmoved soil. So we are moving towards a more formal pronunciation of what we now call residuum. So it's still evolving within the publication as they move towards the publication end date. And then they also describe alluvium, which has been conveyed from a distance by water and exists in thick beds. So they knew and they described as the alluvium having been moved by water. The term geest, geest, or guest was then subdivided based on various amounts of silex. The subdivisions included granulated soil, hard pan, upland loam, upland clay, and lowland loam. I thought the hard pan was interesting there, and I really need to find more of these publications to delve in further of what they mean by certain terminologies because there's still some nuances surrounding them. Practices that were considered as agricultural at the time, such as clovering, marling, and admixing with sand, were recommended for each subdivision. The Geological Survey of Albany County, New York, inspired further investigations to increase the coverage from county to state-based geological surveys and set the stage for the next wave of geologic surveys and soils investigations. We're moving forward, and in 1820, the publication of Albany County, the application of geology to agriculture by means of the analysis and classification of soils, was a groundbreaking moment in the timeline leading up to the establishment of the Soil Survey Program. This county-based publication led to the idea of funding larger surveys to address increasing agricultural concerns and scientifically and politically. And again, we're coming down, we're actually moving to the state of Massachusetts in the order of spotosols, or as we say in the South, spotosols. I'll southernize that term for just a little bit there. My apologies. In the wake of state legislative opposition, Massachusetts was the first state to authorize, fund, and complete a similar survey. So people had started to notice the 1820s publication in a good or a bad fashion. Dr. Everett Hitchcock, a minister of gospel, professor of geology, and later the president of Amherst College, was selected to lead the survey. The final report of the Geology of Massachusetts included geological and biological data and a section concerning the analysis and classification of soils in Massachusetts. The map included in the publication is known to be the first of its kind to actually show the character and the distribution of soils. A few examples of the classification of soils from that report included alluvium, which was separated from rivers as and peaty, graywackle, which was conglomerate, slaty gray or slaty red, clay slate soil, limestone soil, which was separated into two categories of magnesium and common. I'm still not sure what the common referred to in this publication. The final report on the geology of Massachusetts was published in 1846 and was soon followed by similar surveys. I'm going to move forward a little bit in time here and go to Mississippi, just a little bit north of Jackson, in the soil order of alpha sols. And we're looking at the advancement of these state-based publications. Eugene Hilgard, a Bavarian-born geologist, would become the next great mind in the evolution of soil science in the United States. His work on the Report of the Geology and Agriculture of Mississippi was, in fact, revolutionary. David Rice Gardner wrote a thesis called The History of the National Cooperative Soil Survey in the United States, and I mine mostly from his publication in addition to several others. And he states in that thesis, Hilgard's understanding of the principles underlying the use of soil surveys and other research was, in 1860, many years in advance of the development of techniques of soil characterization, soil analysis, and field mapping adequate for the full application of such principles. His classification of the soils of Mississippi was significantly different from the geologically oriented systems in use elsewhere. In the agricultural map which accompanied the report, he introduced the additional criterion of natural vegetation in the delineation of such areas as pine upland soil and longleaf pine soils. This is starting to look familiar. In addition to being a groundbreaking geology and soils publication, half of this report was dedicated to being a handbook for farmers, thus introducing what would later be known as soil survey interpretations. You have two groundbreaking moments here. In the agricultural report of the publication, Hilgard discussed everyday problems of soil management in non-technical terms. Among several of his suggestions for better farming practices was his recommendation of circling, which is what we now call cultivation on the contour, as a cure for washes, which is what we now term as erosion. His recognition of soils and vegetation in relation to vegetation and the challenges that farmers faced was unprecedented at the time. He spoke the language of the farmer by speaking in non-technical terms. And we now use this vegetation criterion in ecological site descriptions. Moving forward to 1862, we're back in the Northeast in Spotisaws, and we look at the development of the Soil Survey Program and the National Cooperative Soil Survey not as solely the result of scientific progression alone. Many of the authors of the geology reports that were published at the time were also agriculturists. Most people had gardens or small or large farms with livestock, and being farmers or ranchers themselves, they were very knowledgeable of agricultural practices. Many of the politicians of the time saw the need to fund science-based publications as the agricultural sector and our populations grew. And one such person that really had a connection to several aspects here, drawing from his personal experience with his own lack of educational opportunities, Justin Morrill, a congressman representing Vermont, sponsored legislation that changed the landscape of higher education in the United States of America. The first Morrill Act is recognized as marking the first federal aid to higher education by donating public lands to several states, territories, which may provide colleges for the benefit of agricultural and mechanic arts. The system invited misuse by opportunists, and substantial portions of these educational land grants never, unfortunately, benefited from education. It was bound to happen, right? Nevertheless, land grant support became a substantial factor in providing education to most American children who could never hope to attend a private or a charity-supported school. Ultimately, the Morrill land grants laid the foundation for a national system of state colleges and universities. In some cases, the land sales financed existing institutions. In others, new schools were chartered by the states. Major universities such as Nebraska, Washington State, Clemson, and Cornell were chartered as land grant schools. That's just to name a few. So we go fast forward to 1887 to a U.S. representative from the state of Missouri, and we're landing in the soil order of alpha soils. William Henry Hatch chaired the House Committee of Agriculture in 1887. He was responsible in that he sponsored a bill that gave federal funds initially of $15,000 each to state land grant colleges in order to create a series of ag experiment stations, as well as pass along new information, especially in the areas of soil minerals and plant growth. Right there, that's important, right? Very important that they recognize this from a political perspective. State agricultural stations created under this act were usually connected with those land grant colleges and universities founded under the Morrill Act of 1862. Two big steps here. In the 1800s, ag research was organized with both public and private support. The first state ag experiment stations to remain in continuous operation were established in Connecticut and California in 1875. Similar operations were developed in other states, but a full state ag experiment station system was not created until the passage of the Hatch Act of 1887 by Congress. The act was signed into law by President Cleveland on March 2, 1887, providing annual funding to support state agricultural experiment stations in each state in conjunction with the land-grant universities. This is the first linkage right there, ag experiment stations to land-grant universities. So we're gonna connect several links as we move forward with this presentation. Often confused with an unrelated piece of legislation bearing the same name, the Hatch Act of 1887 made possible the original research and scientific studies that provided information on the application of scientific knowledge to farming, the environment, conservation of natural resources, and rural life. By establishing experiment stations in conjunction with the land-grant universities, the Act provided a continued investment in the nation's future, greatly increased the efficiency of American agriculture as the country's leading industry, and established a research function of the American Land Grant University. In addition, by providing continued funding for state experiment stations, the Act also created a system for the development and training of personnel devoted to scientific research and original investigations in agriculture, and for the education of new research workers, expanding the frontiers of knowledge. So now you're creating this network of education and research, and you're also creating skilled workers. So moving forward to 1890, continuing in the legislative and administrative origins, even with the passage of the Morrill Act in 1862, the federal government was unable to gain cooperation from the southern states to support Black institutions. We're on the heels of the Civil War here. We will travel to Mississippi, to Tuskegee in particular, to the Soil Order of Intasals. I know the most of the Soil Order there is Altasals, but let's do something a little different. To overcome this issue of the southern states not supporting Black institutions, the Second Morrill Act of 1890 was passed specifically to establish and support Black educational institutions. The southern states that did not have Black institutions, by this time, each created one later under this act. Now, I'll just talk quickly about Tuskegee Institute, of course, was created by an act of the Alabama legislature. However, 12 years after that, the state established and incorporated a board of trustees and named the school private. Thus, it is a non-land-grant college in spite of the fact that it was granted 25,000 acres of land by Congress in 1899. This really hits home the triple mission that we want to really drive home here is the land-grant institutions. The concept of them is research, instruction, and extension service. And this link takes you to Prairie View A&M University, which I cited most of the information from this section. They provide a really good table that talks about the evolution, each institution, when they were established, and their sponsor. In addition, their website also has a map of the original 1890s land-grant colleges and universities. So a really good site. More legislative and administrative origins. I know people think, oh man, you know, all of these acts and appropriations, this is actually very interesting. And it gets even more interesting with the Association of American Colleges and Experiment Stations. We're going to travel to Tennessee this time, back in the Soil Order of Altasals. After the passage of the Hatch Act of 1887, the first annual convention of the Association of American Agricultural Colleges and Experiment Stations, which is now currently named the Association of Public and Land-Grant Universities, was held in Washington, D.C. There's a reason why I didn't pick D.C. again for this location, and we'll get to that a little bit later. The association, as I'll refer to it, to kind of streamline this a little bit, had annual conventions, and the membership of this association was the land-grant colleges and the ag experiment stations previously established in the legislation that we just discussed. So during their fifth annual convention, a topic of discussion arose concerning increased college and experiment station participation in the operations of the U.S. Weather Bureau. So here's your connection to the federal aspect. the early beginnings. The Weather Bureau was transferred from the Department of transferred to the Department of Agriculture from the Department of War on July 1st, 1891. Again, we're moving out of the Civil War into the early 1900s here. Opposition stated that the Weather Bureau reports were inadequate for agricultural use and urged that the weather stations should be located at the experiment stations. However, the newly appointed chief of the Weather Bureau, Mark Harrington, encouraged this cooperation with the experiment stations, but did not support the stations on experiment station property due to lack of telegraph and railroad facilities. At this time, there was still need for the technology that existed. If they were too remote, it just wasn't going to work out with the weather stations. In closing of this convention, it was recognized there was a need to investigate the relationship of forest to climate, the reactions of soil and climate, and the influence of climate upon vegetation. The membership, which was the land-grant universities and experiment stations, adopted a resolution supported and established by I.P. Roberts, who was the professor of soils and delegate from New York, and C.W. Dabney, Jr. of Tennessee, who was the vice president of the Association of Colleges and Experiment Stations at that time. You're going to see the name C.W. Dabney Jr. a lot in the next couple of minutes. This guy was everywhere and integral to our formation and origin story. The resolution that they crafted stated, resolved, that in the future development and extension of the Weather Bureau in the special interest of agriculture, the Weather Bureau should organize and assist in maintaining a study of climatology in its relations to farming, in cooperation with the colleges and stations, and that the sphere of this work should be enlarged to include the physics, 31 conditions, and changes of agricultural soils. I'm still researching what the 31 conditions and changes were, so that will come at a later date when I find that piece of information out. This 5th annual convention marked the beginning of federal and state cooperation in ag research and data inventory. It is not documented here that Eugene Hilgard or Milton Whitney, which we'll talk about in a few seconds, were involved in the crafting of the resolution that was adopted. However, they were both present at this convention. From this convention, Milton Whitney and C.W. Dabney Jr. saw not only the value of cooperation between these entities, government entities, but the absolute necessity of cooperation in the light of minimal funding. You know, as Angela Lansbury sings in The Beauty and Beast, tale as old as time, right? And so this connection is the forerunner of what we now know as the National Cooperative Soil Survey, but we'll get to that in a second. Legislative authorization for the establishment of a division of agricultural soils was not immediately forthcoming. In the meantime, however, the Weather Bureau published Eugene Hilgard's monograph on relations of soil to climate. Sounds familiar, right? And published also the first of a series of reports by Milton Whitney, who had undertaken studies in soil physics as an agent of the Weather Bureau. So you have Eugene Hilgard and Milton Whitney working with C.W. Dabney, I.P. Roberts, other members of this association in the production of publications. So we're moving forward, and we're going to go back to D.C. because a lot's happening in the world of Agricultural Appropriations Acts. 1894, we're going back to the Soil Order of Ultisols. And as mentioned earlier, this legislation required to establish the Division of Agricultural Soils was not forthcoming. However, with the efforts of a few such as C.W. Dabney Jr., I.P. Roberts, Eugene Hilgard, Milton Whitney, the Weather Bureau chief, which was Mark Harrington, and many others, it did not take long to set in motion legislation that would lead to our present existence. Key legislation was enacted by the 52nd Congress in the Agriculture Appropriation Act of 1894. This act, as David Rice Gardner says in this thesis, although it lost in conference, a Senate amendment to authorize special soils investigations by the Division of Chemistry contained under the subappropriation for the Weather Bureau authority for investigations on the relations of climate to organic life. Boom. There's your legislative authority. So here we go. We're fixing to evolve very quickly with quite a bit in the world of appropriations acts. On February 14th, 1894, the Assistant Secretary of Agriculture, guess who? C.W. Dabney Jr., who was Vice President of the College Association at the time, helped draft that resolution that we talked about in 1891, which recommended that federal involvement. He recommended to the Secretary that the Division of Agricultural Soils be established. In support of his recommendation, Dabney cited the above legislation for 1894 and the 1891 recommendation of the Weather Bureau chief. And in that, he did talk about resolutions of agricultural societies. The following day, after his recommendations, Secretary J. Sterling Morton, Secretary of Ag, in a memorandum to the chief of the Weather Bureau, Mark Harrington, formally established the Division of Agricultural Soils. On March 3rd, 1894, at a salary of $2,000 per year, Milton Whitney was named chief of the Division of Agricultural Soils. Soil survey publications, as we know them today, did not begin until a few years after that establishment of the Division of Agricultural Soils. One of the first publications the division assisted C.W. Dabney Jr. with was titled Washed Soils and How to Prevent and Reclaim Them. This was published in Farmer's Bulletin number 20, October of 1894. This publication contained etched illustrations of sheet erosion. It also described chemical engineering and vegetative practices designed to both control erosion and reclaim eroded soils. This was the Department of Agriculture's first publication devoted to the subject of erosion. The Division of Soils residency into the Weather Bureau was short-lived. In the same report in which Secretary Morton declared the establishment of the Division of Agricultural Soils, the Secretary moved it to an independent division in agriculture, which became effective July 11, 1895. For the first year and a half, the existence of the Division of Agricultural Soils was purely administrative. With authority only for investigations, the Secretary had established the division and named the division chief. There was some congressional rumbling over such independent actions by the Secretary, who was in those pre-Hoover Commission days, had much discretionary authority than his successors did. But there was no legislative mention of the division by name until the Agriculture Appropriation Act for 1896. This act designated the Division of Agricultural Soils as distinct from the Weather Bureau and appropriated it for the sum of $15,000. Under the Appropriation Act for 1897, the unit, as they referred to it at the time, it's a historical term, became the Division of Soils. So we've changed our name already by 1897. We might as well get used to that. So once the Division of Soils was established, Milton Whitney was the chief. We moved forward to different types of publications. So beyond Milton Whitney and Eugene Hilgard's reports, we're now moving into that federal state cooperative structure. So in 1897, we're going to look at the forerunner of the cooperative approach, and we're going to go back to Tennessee, back in the soil order of Ultisols in Robertson County. In 1897, with the influence of Milton Whitney from the Division of Soils, USDA, a publication titled The Soils of Tennessee set the stage as the first example of the federal state cooperative structure that would later emerge as the primary method of producing soil surveys as we know them today. This publication, again, was breaking records, the first of its kind in many ways. It and the cooperative agreements involved, that's important, involved with the work of, guess who? C.W. Dabney Jr. The basis for soil classification used in the survey was still largely geological, but in other respects, the report was one of the most advanced of its time. The need for both chemical and physical soil analysis was cited, as well as the great importance of careful field observation in the selection of representative soil samples for analysis. In the description of the farmland of Tennessee, extensive soil erosion and deterioration were given as causes for abandonment of an estimated 1 million acres of formerly cultivated land. An additional point of interest, this is, there were several cool things in this publication if you do find it. There were several hand drawings of profile types, of distribution of particle sizes. It's a very interesting publication, and it's not a publication that's a soil survey publication as we know it today, but it's one of those that's a transition of sorts from previous publications to the modern world. An additional point of interest in this Tennessee report of 1897, there was an illustration of a new technique for removing and mounting full-size, quote-unquote, prisms or vertical columns of undisturbed soil to a depth of 3 to 4 feet. This is the kind of the really cool part of this. Well, not kind of, it is the cool part. The idea of preparing and using these soil monoliths apparently reached Tennessee via the Chicago International Exhibition of 1893. Among the Russian exhibits at Chicago was a large display of mounted soil monoliths brought to this country and explained by a Russian pedologist, perhaps a man named V. Williams. This tidbit of information was actually gained by David Rice Gardner in a personal communication between himself and Charles Kellogg. In addition, mechanical soil analysis was conducted by Milton Whitney. This is kind of important to note here too. And the chemical soil analysis was performed by J.B. McBride of the Tennessee Ag Experiment Station. So you have the federal portion conducting one portion of the survey, and you have the state portion conducting another part. Soil surface samples were examined, and some subsoil samples were analyzed. David Rice Gardner mentions in his History of the National Cooperative Soil Survey that the agricultural value and the best methods of management of the different soils are very fully discussed, especial attention being given to the necessity of protection against washing, which is what we now know as erosion, and the maintenance of sufficient supply of humus to the soil. I'm going to scroll back up here real quickly and show you the photos that are throughout this publication, and my internet is really slow. No. Okay. So this is Robertson County. You can see here you have the group of folks, including some children, near Adams Station. And right here in this portion, this is the origins of the soil monolith in this publication that was taken from that exhibition at Chicago. Find that very interesting. This is where we'll land today and eventually end here in a few minutes before we won't go on to the next part of the series. We're looking at the 1899, which is our landmark year, the first soil surveys and the birth of the National Cooperative Soil Survey. We're going to go back to Washington, D.C. for this to celebrate the fact that the 55th Congress passed the Agriculture Appropriations Act of 1899 and May 3rd of the same year an annual appropriation of $16,000 with the authorization. Here you go. Your authorization is expanding. We're getting more specific now, and we get a little bit more wiggle room to do what we do today. This is looking towards the future. Investigation of the relation of soils to climate and organic life. We had that originally, right? And investigation of the texture and composition of soils in the field and in the laboratory. And if you read a little bit more about Whitney was very interested in the texture of soils. And when we delve more after this series into what the first soil surveys get into, you'll see that they start looking at particle size analysis in those soils, which they did not do that in previous publications. Whitney began field operations of what was to become the National Cooperative Soil Survey in a prophetic letter of transmittal to President William McKinley, accompanying the initial publication, Field Operations of the Division of Soils, 1899, Secretary James Wilson wrote to the President. It covers not only the most important work of this division, but is, in my opinion, regarded in the light of the possible results of the information which has been secured thereby, the most important work of this character ever undertaken by any country. The area mapped in 1899 in the first soil surveys totaled 720,000 acres of 4 separate surveys: Cecil County, Maryland, the Connecticut Valley, which includes Massachusetts and Connecticut, the Salt Lake Valley of Utah, and Pecos Valley, New Mexico. All but one of these soil surveys was made in cooperation with state agencies. Initially, in the cooperative process of making and producing soil surveys, Milton Whitney established national standards and methods for soil surveying. The agricultural experiment stations would be cooperators, but the published soil survey would be issued by the Division of Soils. The survey methods used would conform to Whitney's methodology, not to the standard of the individual experiment station. The series of published surveys would have a uniform format and be recognized as part of a national inventory. Originally, the National Cooperative Soil Survey was a cooperative undertaking mainly involving the United States Department of Agriculture and the state ag experiment stations. During its inception, other federal, state, and local agencies cooperated on a smaller scale. As soil surveys were recognized of value across the nation, the cooperators that originally worked in conjunction with the Department of Agriculture and the experiment stations on a small scale began to grow and take on more prominent roles in the development and production of soil surveys. And we'll go through this as we move through the three-part series and talk about other federal and state entities that come into play with us to produce soil surveys for various needs. In many cases, the terms Soil Survey Program and the National Cooperative Soil Survey are used interchangeably. And the reason why is because it would be very difficult for one entity to exist without the other. And you can see that in this evolution of the events leading up to 1899. You know, the land-grant universities needed the experiment stations. The land-grant universities and the experiment stations needed the federal sector. So back to, you know, tale as old as time as far as minimal funding, minimal staff. This is something that we've known since this time, that it was really hard to produce the type of product that the public needed without this type of partnership, without this type of cooperation. And luckily, many of the politicians at the time, even though they had opposition, many of the scientists at the time who had this ag experience in their daily lives saw the need for these larger based, county-based, state-based, and then we evolved to publications across the nation. So we'll talk about that a little bit more in our series. And Paul, I think I'll conclude here because if I go any further, we'll probably take up a little bit too much time.
All right. Well, thank you, Jen, for that. Are you ready to take a few questions?
I hope so. We'll try.
All right. There was just a few comments. One was the term hard pan in New York was mentioned, and someone said it probably meant till.
Yes, that's what I had originally thought. The definition, it wasn't defined in David Rice Gardner's thesis. And I noticed that really getting into the weeds of a lot of some of these publications was difficult to do, but that was my assumption as well.
And another kind of comment on some of the wording. Common, maybe just limestone, calcium carbonate, manganese, maybe dolomite.
Maybe,
So,
yeah.
Suggestions that way.
Maybe.
All right, here's a little longer question. I think you mentioned that the U.S. Soil Survey Program is the longest running in the world. What do you think has contributed to the longevity of the program when compared to similar programs in other countries?
The cooperative. Without this establishment of the state, along with the federal partnerships and cooperation, there's no way it could stand alone. I think that is, I wouldn't describe it as a fault. We're just different, right? As these programs evolved, each country, each nation had its own issues to deal with. And with our politicians being so ingrained into agriculture in their daily lives, I think that's a big driver. You know, there's nothing like experience to fuel your passion. So the passion of agriculture, the passion to feed our people, the nation, and then eventually in modern times we feed the world. Without that passion, it wouldn't drive someone. You saw Justin Morrill's passion was that he couldn't afford the private schools, right? He couldn't afford the expensive education, and his passion was making this education accessible to more people, to more impoverished people in this country. So that passion led to another passion, and then they started to connect the dots. And the whole essence of the cooperative is what's given us this longevity, and that we still have this passion to agriculture. Would we have this passion if we were tied any other place in the federal government? I'm not really sure. But the ag experiment stations, the land-grant universities, the creation of the 1890s universities, and then the work that went through all of these universities and experiment stations in conjunction with the federal is what's given its longevity. And now that intertwined connection is what makes us interchangeable in the terminology between the Soil Survey Program and the National Cooperative Soil Survey.
Excellent. Jenn, I might have missed this off the top. You mentioned this is kind of the part one of a three-part series. Am I correct on that?
Yes, you are correct. When we did the dry run, we realized there is absolutely no way we could cover 125 years in 30 to 40 minutes. So the second series, it depends on where we'll stop. And I'll show you just a really quick tidbit if we've got a few seconds. We'll cover those first four soil surveys that were as part of that 1899 landmark year. And we'll talk about those, and then we'll move forward to more evolution in both the Soil Survey Program and the National Cooperative Soil Survey. Maybe delve more into soil taxonomy. We'll delve more into how the soil surveys look like what we have today. We'll delve into the beginning of the National Cooperative Soil Survey conferences. We can't go through this without talking about the inception of the conferences. And then get into the 80s and the 90s and the 2000s into the technology and how the advent of technology has really driven where we are today and changed the way we look at our product and what we provide to the public.
Very good. And then I guess my last question, Jenn, was this a team approach to developing this, or was this something that you crafted? Or
I started this in a story map for the National Cooperative Soil Survey National Conference in Rhode Island. I delivered a portion to it to the undersecretary. He was in attendance to our into our meeting. And I only got like a few minutes in. That was all I could do. We didn't have enough time. And it was a gigantic story map. It went into the evolution of our cooperators later on in the evolution, Bureau of Land Management, Forest Service, National Park Service. And I did do a lot of research into the book, the U.S. Profiles book that is hopefully in like quite a few people's offices. Profiles in U.S. History, that's the book, and it talks about how other entities tried to resurrect their own soils program for various needs and purposes, but it all drives back to this legislative authority and how this cooperative approach and structure was established. And that, again, back to that longevity where others just couldn't make it work in the longevity realm, we made it work because of that cooperative nature. And of course, scientists, there was a lot of tussles and arguments that were kind of exciting to read about. We won't get into the wrestling matches in the scientific world or the legislative world. It happens. It's the nature of it. But this was one that I had crafted a long time ago when Paul and I were doing story maps quite a bit back in the day. And I wanted to make sure that we went across the soil orders map.
All right. Well, very good. I do not see any other questions in the Q&A pod. So I think we just thank you, Jenn, for the presentation and the great information on the history of why we're here and why we are all looking forward to another 125 years of soil survey. So Paul, you bet. Thank you, Jenn. Paul put up on the screen here the next webinar is coming up June 11th, 2024. So make sure you schedule some time to get together with us all. Appreciate the time. Thank you again, Jenn, and looking forward to next time. Thanks, everyone.